Hello everyone, welcome back to my channel. In today's video we will look at how to use regular expression in general but in Dataweave. If you watch till the end of this video, please don't forget to like, share and subscribe. That way I will know that I'm making useful content and it inspires me to make more videos. Now if you are not aware already, regular expression is a function which takes some input and it gives an output based on a pattern matching algorithm. There are many different programs both in Windows and the Linux world which has the regular expression functionality inbuilt. Similarly, Dataweave also supports regular expression while using some functions, and we will be shortly looking at them as I explain with some examples. Now first, let's look at some basic elements of regular expression. So let's open our favorite Dataweave editor. Alright, so I will use the match function of Dataweave for the rest of this video. The match takes an input and an expression after it. So there are two parts for a match function, an input and an expression. All regular expression patterns should be confined between two forward slashes. If you do not specify these slashes, then you're just matching a string with a string. Okay, let's proceed. If you try to match one character with another character, then you do it like this. So let's say your input is ABC. So you do ABC match forward slashes, and here goes the expression. So I will match it with ABC. So basically what's happening here is that each character is being matched character by character. Alright. Now if I do not give the C here, it's not going to match because it has to match the whole string. Now let's look at some regular expression operators. So first we have a dot. And the dot is also called as a wildcard operator. So let's use this dot here in our match expression. Since I have already matched A and B and C is left, I will just match C with the wildcard expression, wildcard entry. As you can see, it has successfully matched ABC and given us the desired result. Next we have asterisk. An asterisk matches 0 or more elements for that character which precedes it. So if you combine a dot with an asterisk, it will match the whole file or the whole string. So let's remove this and add a dot first. So the dot is going to match the character A, and if you add an asterisk at the end, it's going to match the whole text. So if you provide anything more than ABC, it's going to match. It doesn't matter what kind of character it is. It can be alphanumeric or some kind of special characters or just numbers. Next we have a plus operator. So let's note it down here first. Asterisk is 0 or more. Next we have a plus operator which matches one or more occurrences to the element which it follows. So if you do not wish to use the asterisk, replace it with the plus and it's still going to work. Okay, now let me clear this. I will again explain. So you have ABC and you're trying to match it with ABC. In this case, you're trying to match ABC with ABC, and it's not going, if you try to provide any other input apart from what's there in the expression, it's not going to match. This is when the plus operator really helps you. So in here Imagine I add an extra B character. Since this is entirely different, it's not going to match. Now I will add a plus operator after the B. As you can see, it's basically searching for one or more occurrences of B. What this is trying to tell is that the plus operator is going to accept one or more occurrences of B in the input. So if I keep adding more B's, it's going to match. Okay, good. So there is one more operator which is question mark. So there is question mark. Now how to use this and what is this? So question mark is nothing but 0 or 1 occurrence. A question mark matches 0 or 1 occurrence of the preceding character and not any further. So if I replace the plus operator with a question mark, it will not match this input A, B, B, C. So let's take a look at it. As you can see, it's not matching it because there are more than 1 B's here. So if I make it as 2 B's, it's still not going to work, but if I make it as 1, then it's going to work. Alright. And if I remove the B, still it's going to work because it says that 0 occurrences is also allowed. So whatever I have explained till now, these operators are called qualifiers, and some people call them quantifiers. Okay, so what are these quantifiers? We have question mark, we have a plus, and we have an asterisk. So these are the quantifiers. All right, and we have also looked at a dot. Okay, now let's look at some basic characters similar to the quantifiers. There is dollar, and let me just show you how it works. So if you have this, now if you add a dollar after C, so dollar says that anything which precedes it, it should be the last character in your input string. So this matches the end of the string. In this case, it is C. If you replace the C with the D, it won't match. Similar to this, we have a caret. This matches the start of our string. So if we do this, and let's put back our C here, so it's going to match. If you have anything other than A, let's say E, then it's not going to match. Now here is a special case. What if your input string has these operators in it? How do you match something like this? So in order to make this work, you would think, let's add a caret here, but it still won't work. So what we have is another operator which can help us in such cases. It is the backslash. Basically, it's the escape character. So if you do this, it will work. So far good. Now I want to match my start of the string with either A or B. So let's say I have a B here. Since it's not going to match, I want to either go with A or B. What we have here is a B as the start of my string, but I want to match either A or B. Now in order to do this, you have to use the pipe operator. This is going to match either A or B, which is the start of our string. Now let's say we have spaces or tabs in our input string. So how do you match something like this? So you would think, let us add a space in my expression like this and it's going to work. Of course it will, but the right way to do it is to use the /s operator. So instead of this, I would do this and it will work. Now let's clear this up. Now let's try this one. So we have something here. We have an A and 3 spaces and a B. So how to match this? So there are 2 ways to do it. The first way is to add A. First we'll match with A, and then we'll add a space, and we add a space, and then another space, and finally we add B. But what if there are more than 3 spaces? You cannot add that many spaces in your expression. It's going to look awkward. So the best way to do this is, if you know the number of spaces between your A and B, specify /s, and then you have to use the curly symbol. In that you have to provide the number of spaces which you found here. So there are 1, 2, 3, 4, 5, 6, 7, 8 spaces, and I would mention 8. So it's going to match. So the curly works in a way that it matches exactly the number of occurrences of the preceding operator based on the number given within that curly. Remember, you can also use plus instead of curly 8. So if I just do this, it's going to work. But the right way to do is use the curly operator in this case. And one more small problem with using plus operator, or let's call them as quantifiers, right? That's the right terminology to use. So why I do not recommend to use the plus operator in this case is that there is no upper limit to plus. All right, now if I have extra spaces here, it's going to match it, but with a curly 8, it's only going to match that many spaces provided in our input, and it's not going to match any further. Now let's clear this and let's recap what we have discussed so far. So we have learned how to use /s, a caret, a dollar, a plus, a dot, a question mark, an asterisk, and a curly with a variable number provided in between. So let's clear this. Now let's take a look at this example. You have this input string ABC, ABC, ABC. Match to /s. Now how to match this? Okay, so there are 3 ways to do this. The easiest and the dirty way is to match character to character like this: ABC, ABC, ABC. The next way is to do curly. So let's see that. ABC, curly braces open, and you provide the number of occurrences of ABC, which is 3, and you close it. Wait, why is this not working? It's because curly 3 only applies on its immediate preceding character, that is C. So the actual match you need to use is the group operator, like this. So the way the group operator works is a bit different. It matches all possible combinations of that group's existence in your input string, which is why you are seeing an output like this. So these are all the possible combinations which can be extracted from this input with the group ABC. Now if you try to give something like 4 here, it won't match because there are no 4 occurrences of ABC, there's only 3. Similar to the group operator, there is the square braces character class operator. Okay, first of all, these things are not called as operators, whatever I'm discussing so far. I don't have a better way to describe them, so I'm calling them as operators. So please go along with me. As I've said, next we have is a character class operator, which is denoted by the symbol square braces. So in order to use this, you can do something like this. But it didn't work because you were just looking at one occurrence, but there are 3, and so you had to expand it. In here, it's looking for the word ABC as a unit, but it's still not matching. And if you add the plus operator at the end, it's going to make it work. But what if your input has something other than ABC? Let's say you add the characters D, E, F before the ABC. Now it's not matching again. Why? Because your word is starting with D, E, F, but our match pattern only starts with ABC. This is where the class operator is handy. It can also support range operations, which is denoted by the symbol hyphen. So if you do something like this instead, it's going to match everything. So what this is basically saying is it's going to match any character which starts with small a till z. Now we can also add numbers to our input. But here is a problem. We did not add numbers in our range. So just to expand our range for numbers, you start with 0, you put a hyphen and 9. Now it will work. Okay, if you like this video so far, please click the like button and it helps. Now let's go back to our group example again. So what we have here is ABC, 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 match, forward slashes, and you give the group ABC and you try to match just 2 occurrences. So in this example, we are asking to match only 2 groups, but our input has more than 2 groups. So to simply match 2 or more possibilities, you add a comma after your 2. So what this means is that it's trying to match the least possible occurrences and there is no upper limit. Okay, so if you add more ABCs here, it's going to match. Now let's go back to our character class example again, which is the square braces. So imagine if you have a mobile number in your input. How do you ensure to match any input which has anything other than numbers? So let's type a mobile number here. So in order to match this, I would do match forward slashes, and I would typically add 0 to 9 and I would do a plus. All right, but there is another way to do it. If you do the range from A to Z, and if you want to match an input which does not have A to Z, then you would simply specify a caret before your range. So what this basically telling is, in your input you have numbers, in your match expression It's simply saying I want anything which do not have this A to Z characters. Now you can simply expand this to any other character. So in my phone number, if I accidentally have a hyphen or an asterisk or any flower braces, this is still matching. So in order to not match, you just need to expand this range. I'm going to provide a hyphen here, I'm going to provide an asterisk, and I'm going to provide these things as well. As you can see, now it's not matching, and if I remove these special characters, it's going to match. So this is a great way to ensure that your mobile numbers are not having any special characters, which is going to break your code. Now there are some other things which I haven't covered, such as /w, which is used to match anything like words, /d for digits, /t for tabs, /W, which is the opposite of W, and /D, which is the opposite of /D, and we have /B. Now let's briefly look at these things. So in our input we have ABC, and if you want to match just the words, then you can do something like this. Now if you want to match digits like 1, 2, 3 in your input, then you can use /D. Surprisingly, /W also works with digits. The opposite of /D and /W is /W and /D. So if you just replace this with D, it's not going to match. So explicitly it's saying you do not want to match anything which has to do with a digit. Next we have /T, which is similar to /S, and /N. Okay, I forgot to add it here. /N, which is nothing but line feed, so it's going to match line breaks. More precisely, new line breaks. And /R for carriage return. Of course, I forgot to add that. /N and /R, but these are not really important. Now this is a good time to talk about other Dataweave functions like matches, find, and scan. Matches, find, and scan. So let's take a look at matches. Replace your match with matches, and let's try to match this first. As you can see, matches simply returns the expression yield to either a true or false. Now let's take a look at find. So replace matches with a find. Find simply returns the position of the match in your input. Okay. Finally, we have scan, which is really useful more than a match. So this is much more important than a match. So the main difference between match and scan is how they operate on the input. Scan versus match. Match takes an input to its entirety and matches it against a pattern. It won't help much if you're looking for certain parts of the input for a pattern. It always has to match your entire text. So doing this will match ABC, and doing this won't. So if you have something more than ABC here, like it's not going to work. As you can see, this is trying to match the entire string and not just parts of the string. So it will find your pattern and extract it out. But if you replace match with a scan like this, it will find your pattern and extract it out. So simply remember this: match is for matching exactly the pattern given, and it gives you the output, whereas scan is to extract whatever is in your input text. Hope this is clear. So adding few more characters here, DEF, we will be able to find it and extract it. So you have ABC and DEF, both are matching with as a words, and so it's extracting it and it's giving this output. Now to group them together, you can just simply apply a flatten on the top of it. Next, there are 4 more features of regular expression I haven't talked about yet. It involves something to do with groups. These are positive look ahead and look behind, negative look ahead and look behind. So let me write this out. Positive look ahead, positive look behind. Next we have negative look ahead and negative look behind. So I don't want to type, I'll just paste this here, and negative. So what are these things? Let me explain. So let's take a look at an example and see how useful these 4 features can be. By the way, these are the kind of things which are considered as advanced regular expression operations, but it's really simple. So let's see this example. So in our payload section, I'm going to add some random text, okay? And let's make this as a text instead of JSON, because we're having some kind of random data here. So I'm going to type some random text here, give some spaces here and there, and add some new lines and spaces. Now here I would like to provide a number, phone number possibly, and some character and some other numbers, and I'll type from, and I'll say google.com, and I'll just type in the word database and some other extra characters. So if you look at this, in here the from follows a website host, google.com. Let's say we want to fetch this google.com. How do you do it? Maybe like this. First let's clear this, scan and do forward slashes f from. Okay, so I'm looking for the word google.com. So first I need to get some reference here. The reference is from, so my google.com comes after from, and there is also a space. So we have from, and then there's a space. For that I'll use /s, and then we have a range of alphabets A to Z, and again this is just matching the first character G, but I want something more than G. I want the word Google, so I'll just add a plus, and it's going to match me Google, but I want google.com, so I will add a dot. Now there's a problem with this. As you can see, I want to extract google.com, so I just want to match google.com, but in order to match it, I'm using some kind of reference word called as from, and this from is also appearing in my output. So this is where we use positive look behind. The syntax goes as follows: payload scan, and you just put this from in a group, but you use a question mark and a less than symbol and an equals to. Okay, So this is matching. So what basically this is trying to say is that we are trying to look for the word from, but we do not want it to be a part of our output. Okay, we're trying to match for from, but we don't want it to be a part of our output. But this isn't perfect because we're still seeing some space here. So let's move this /s into our group. Perfect. Similarly, when you have something after your desired match result but do not want to include it in, then you use positive look ahead. So say you're doing this. So this is how you do it. So I will add a /s and I will add the word and. But again, this is wrong because we're not actually doing the look ahead operation. This is simply trying to match the space and the and. So to correctly do this, you just need to wrap it in a group. Okay, it always starts with a group and a question mark symbol, and you give an equals to, and you close the group. Now it has matched it perfectly. So if you observe the difference, a look behind has a question mark, a less than symbol, and an equals to. A look ahead has a question mark and an equals to, but there is no less than symbol. All right, so this part is our look behind, positive look behind, and this part is our look ahead, positive look ahead. Now the opposite of these two things is the negative look ahead and look behind. So let's say in your input text, instead of and, you have an or. All right, so instead of and, you have an or. Now this won't match as we know it because it's not followed by the word and. All right, it's followed by the word or. So since you want to match it, you're saying for a negative look ahead, you replace the equals to symbol with an exclamation symbol, and it's going to work. So what this is trying to say is, I do not want something to follow my text with the word and. Since you have or, it's matching. But if you have something as and, it won't match. Right. And by the way, if you observe this, it's still matching. So what's happening here? As you can see, this is not a group. All right, it's trying to say that it do not want to match something which has immediately a space and an and. So we still have a space and an and, but if you include the word m, it doesn't start with a space and an and, so it's still matching. All right, now similarly, let's try to bring this back. So similarly, if you have the word to in the place of from here before google.com, and if you want to match it, so you do not want the word from, then you have to do something like this with your look behind. So first let's replace this from with a to, and it's not going to match, and we're saying that I do not want something to precede my google.com with a from. So what do we have here? We have to, so it's going to match, right? So this is called as a negative look behind. All right, let me copy this and paste it here. So that's it. You have learned regular expression with me in general, and you also learn how to use it in Dataweave. You can practice with a variety of samples, and there are some good regular expression descriptor websites on the internet. Just search for the word Regex and you would find it. So these regular expression descriptor websites can expand your regular expression and describe what is happening within. If you have any doubts, please put a comment. By the way, there are some even more powerful Linux programs like awk, sed and grep. I shall make a video on it soon, so keep an eye out for it. Have a nice day. See you in another productive session. Goodbye.